Cool. Hi, guys. Welcome, welcome. If you're Algebra 2, adios. If you're Pre-Calculus, hi. I am currently fixing something that apparently was broken. So give me a second. How are we doing today? Throw it in the chat. We'd love to hear it. Great, great, good. Tired, yeah. Good but tired. Yeah, same. Sleepy. I feel you. My bed is just like so close and I just could like roll into it. Yes, for sure. And I need to get some coffee after this. These 9 a.m. classes, man, y'all, pretty early. Did you guys at least get to sleep in because you're not till 9:45? Or were you still awake at like 5 a.m. because your mom was like, it's time to get up? No one got to sleep in. This is so upsetting. Okay, team. I'm gonna go ahead and throw this attendance link in. Attendance link is there. The password is in. So attendance. Sleep is for the weak. No, it is not. Sleep is for the healthy, Galilee. Let me go ahead and find these slides. Slides. Not these. I need the Breakout slides. Guys, I found the best gift for today. Wow, it would help that if I actually shared it with you. Share screen. Dun, dun, dun. Can someone repost the link, please, for the attendance? Repost the link. Yo, shout out to the people who are telling me that their cameras can't, like why their cameras can't be on without me even having to remind you. Thank you so much. I see you. Thank you, Emma, for reposting the attendance link. That's awesome. Guys, can you see my Tater's Gonna Tate GIF? Yeah, it's awesome. Whatever. Galilee loves it, even though she's rolling her eyes at me. Guys, happy National Potato Day. Last Tuesday was National Fajita Day. Today, National Potato Day. If you haven't noticed yet, I love me some food. It is awesome. So question of the day, would you rather have unlimited French fries made from potatoes or potato chips also made from potatoes? We had a rousing debate in my earlier class. So blow up the chat. Janet's like, don't make me choose. I choose both. Fries are way better. Fries. Wow, lots of fries. Ooh, Emma, potato chips, fries. Wow, it's like a repeat here. Chips. Wow, solid 2 for the chips. They asked me what I was thinking about this question, and I just replied tater tots because tater tots are better. Animal fries are good. Yes. My boyfriend used to work at In-N-Out, and so he knows all the recipes. So from time to time, he likes to make the animal fries at home, which is crazy. Nice. They're not as good as at the restaurant though. Fries. Lots of fries. Wow. We're a big fry game. I hear you. Okay. I'm gonna go ahead and after everyone looks at my cute GIF, Tater's Gonna Tate potatoes. No, potatoes gonna potate. It's very funny. Was proud of myself at 11:30 p.m. last night. I'm gonna go ahead and stop my share. If someone can one more time put the attendance link in the chat, that would be great. Thank you to those people who have messaged me about why their cameras can't be on. You are also great. I am gonna try to use my iPad to screen share today. Hopefully it will be better for you guys. I know our computers are super slow. One more person just jumped in, so if we could repost the attendance, please. Repost the attendance, porfa. Thank you so much. All right. So for today, you need paper, pencil, and assignment 3. We are going to jump in for today. I did want to respond to your feedback. Thank you to the 25 of you who filled out the feedback form. That gave me so much good information about like how class is going for you and like what's going on. So that is awesome. Thank you. It also, I was glad to see that it's working out well for most of us. It's okay / good and bad, but there was no one who was like, honestly, miss, it's terrible. So I was glad to see that. Some positive feedback that came from this class. One was, I like the vibes. I love that. And some people saying that it was their favorite so far. I mean, it's my #1 goal in life to be your favorite class. So I'm glad that that's working out for some of you. I know I still have some of you to convince, but we'll make it happen. One person said, or a few people said, I like that you allow us to have freedom in the style of notes that we choose to do. Appreciate that. I will try to continue to let you have that freedom unless I come up with something that I think is good for all of our brains. And then another piece of feedback was, it's very streamlined. I feel like my time is being used efficiently, which is, I love efficiency. I love it. So I'm so glad that you feel that way. If you ever feel like I'm wasting your time, please let me know. I will not be offended. I will figure out how to not waste your time. So please do let me know, because I take that very seriously. So those were the goods. The things that we can change. Somebody said, I think that the only bad thing is that we have to do everything by hand. To that, I'm like, I'm cool if you type, or if you want to like do it in a different way, that's fine. My only request is that you tell me you're thinking in some way. So if you want to record a video telling me what your, like how you would solve this problem, cool, I'll watch your video, that's fine. I'm okay if you type, I'm okay if you write like chicken scratch. I just want to see what you're thinking. Some people ask me to slow down a bit. I totally hear you, especially on that last note. I think that we went really, really fast, and I both talk fast, so I will try to slow down a little bit there, as well as I tend to keep things pretty fast. So I will also try to slow down. Thank you to the people who named that for us. And then my favorite feedback was, make the breakout groups less awkward, and hopefully we have the chance to choose our own groups one day. So I hear you on wanting to work with people that you already know, especially because we can't get to know each other in this space very well. So I sent you to that end, sent you guys an email. We're gonna practice breakout rooms today. I don't know if they're going to work, but I tried something. The reason why we haven't been able to have breakout rooms, why it's not like easy to do that, is because in order for me to pre-assign breakout rooms, I have to, you all have to have accounts on Zoom, and you can't, because you guys are just clicking the link, you actually don't have Zoom accounts. And so what that means is that I'm doing like a workaround for today to see if it will work. I make no promises, but we'll try it. We may just have to figure out how to get you Zoom accounts. I don't know. But I am trying. The ultimate goal is that you would have breakout rooms together, so that you can like get to know each other, so you can continue to get to know each other, as well as work with people that you like already know and work well with. So thank you to those people who emailed me back. Cool. So any other questions regarding the feedback that I just did? You guys can jump off mute, or you can jump in. Any other questions? Everybody's feeling like partially decent on that? Cool. Okay. Does everyone have paper with them? Yeah? See David's thumbs up. Araceli's thumbs up. Love it. Kayla gave me a head nod. Great. Okay, team. We are going to jump in. I'm going to try to go slower. So if there's actually a button that says please slow down in your little participants window. So if you press that button, it will be, you can tell me to slow down. You can actively tell me to slow down. Otherwise, let's get started. We're going to warm up with this question here. So this is f of x. And then would they give us an equation, or I've given you an equation, f of x equals this. So the function of f equals -2 x plus 3 to the square plus 4. Let's think about this. What is the name of this function? Thinking back to our last couple classes. What is the name of this function?
Quadratic.
Quadratic, yeah, for sure. This is a quadratic. So what does it look like? What's its like basic shape?
Parabola, like a U.
Yeah, parabola. So it looks like this, right? It looks like this. Then negative is going to flip it over. The 2 is going to make it skinnier. The plus 3 is going to move in the negative direction 3. I don't know if this is going to be the right direction on this camera, but we'll go this way. And then the plus 4 is going to move it up 4. So we know the graph is like somewhere over here on the graph. We'll get there. For right now, all I want you to do is I want you to find f of -4. Can somebody tell me if we see f of -4, what are they actually talking about here? What do we need to do?
Substitute the value for x.
We're going to substitute the value for x. So x is -4. Go ahead and do that on your own. I know you've done this like 1 million times. So we would have -2, -4 plus 3 squared. Somebody help me out for this first one. What would I do first?
-4 plus 3.
Which is -1. That's going to be squared. What's -1 squared?
1.
+1. Yep. Which is being multiplied times -2 and added to 4. So I've got -2 plus 4, which is
2.
2. Yeah, it's 2. Cool. Go ahead and do that for f is -1. I'm sorry, f of -1 and f of 0. Go ahead and privately chat me your answers when you're ready. When you've got the first one, go ahead and do the second. See a lot of -4s coming for the first one, right? -4. If I agree, I do agree for that first one. If you did not get -4, go ahead and check it out. Go ahead and message me when you got the second one. Seeing a few, -14. -14 is coming in from the crowd. I also got -14. Cool. Wait, take a second to finish that up if you need to. Nice. Getting lots of -14s. Awesome. Perfect. Awesome. All right. So for our equation, we have the same exact equation here. I just went ahead and wrote the answers again here, right? So f of -4 was equal to 2, and f of -1 is equal to -4, and f of 0 is equal to -14. In the same way that we were talking about this equation when we were just chatting about it at the beginning, this is the official graph for f of x, right? So we could see like, oh yeah, it was flipped upside down. We did make it skinnier. We did move it over 3 and up 4, right? So you can see that this center vertex right here is at -3, 4, right? So we can see that that's what's been shifted here. So for these, I could tell 2 of these answers from the graph. So let's say I didn't do any of that math, right? I didn't do any of that math. I could have told you that -4, f of -4 was 2. Does anyone know, looking at the graph, how I could do that?
You're meeting a point in your parabola.
Yeah, I'm reading a point in my parabola. Tell me more about that, Gali.
So there's like, it's kind of like a slope of your parabola. So those are the first 2 points you can acknowledge. So your slope would be like a -2, as you can see from your equation already. And then you have 2 other points, but they aren't as clear when they touch the x-axis.
Yeah, they aren't as clear. I like what you said about slope here. So we kind of went down 2 and over 1, down 2 and over 1. But then when I go to like my next point, it's kind of like if I'm going to go over another one, I'm like way down here, right? So because of that square, because of that parabola shape, we're going here. I would argue though that even if we didn't have this, even if that wasn't there, I could still tell you that f of -4 is 2. Does anyone know how? You know how we say that it's f of x? This is f of x, right? And then we literally took out the x's and we put in the -4. Right? We took out x and put in -4. So x is -4. And then f of x, you probably know, is a fancy way of writing y, right? That's usually the explanation they give you when you start learning about it in Algebra 1. F of x literally means the function at the value x. Where's the function at the value x? Well, that's the y, right? F of x is equal to y, so y is 2. So I can see if x is -4, if x is -4, y, the function, is at +2. Can anyone tell me in a similar way, like what would the coordinate point be for this one?
-1, -4.
Yeah, -1, -4. Thanks, Emma. So I can see here, if I go to -1, if I go to -1 on the x-axis, the function is at -4. Right? What would f of -3 be? My x value is -3. What's my y?
4. 4.
4. Yeah, 4, because if I go to -3, my function is at 4. So these pairs, when you're solving, you're actually just finding points on a graph, right? Points on a graph. So I made the argument earlier that I could tell 2 of these. I could tell this one on the graph and this one on the graph. Why could I not tell this one on the graph? How come I had to actually do algebra for that point?
That number's not shown on this graph.
Tell me more.
So on the graph, it only goes up to -6 and +5 on the y-axis, and you're solving for what's the y-axis number, and it only goes up to, it doesn't go up to -14.
Yeah, exactly. If I'm looking at where x equals 0, thank you, Emma. If I'm looking for where x equals 0, this function, it's going to eventually hit -14. That seems to make sense, right? It's going to eventually hit negative 14, but it's not shown on the graph, right? So this one, not shown. However, we know that that is the correct answer because we were able to do it algebraically. So when we have functions, we can use a graph to check our work or to create our work, right? We can use a graph first if the graph shows the answer, or we can use the function. Or we can use the function. Are there any questions at this point? And I can send you guys these slides as well when we're finished, so you can jump in. Cool. Okay, so graphs and equations are the same, and the reason we know they're the same is because there's an algebraic way and a graphical way. So then if I can do it that direction, like if I know what x is, can I find y, right? It's that we want to really think about, like, if I know what y is, can I find x? So this question says the graph of f of x, which is here, clearly crosses the x value or the x-axis at a value between -4 and -1. So somewhere between -4 and -1, it touches the x-axis, right? I can see that point right here. Based on our computations, how could we justify the guarantee of this occurring at some value between x equals -4 and x equals -1? So this is how an AP test might ask this question, right? We kind of want to break it down. So it says, based on our computations, so based on the algebra that we did, right? Based on what we know the value is here and here, how could we justify, so how could we say it for sure, that this occurs, what occurs, that it's crossing the x-axis? So how do we know for sure that it's going to cross the x-axis if all we know is this point and this point? What could we say?
You have x-intercept points, so it's obviously going to be crossing the x-axis.
How do I know that I have x-intercept points?
Because they gave you the -4 equals x and the -1 equals x.
Well, sure, but what if they were just like, here's -4, like here's a point up here, and then here's also a point up here? Would we be able to say that it crosses the x-axis?
Nope.
No. So the reason that we're able to say that that it must cross the x-axis at some point is because we have one value that's positive and we have one value that's negative. So if we have a positive value and then over here we have a negative value, then at some point it must have crossed that x-axis, right? So if we have one positive here, one negative, must have crossed because we had to get from the positive to the negative. Right? Kind of a strange thought, but we'll keep thinking about it. We'll keep working on AP prompts too, so it's okay if we can't break down this language. So we can also find x values when we know f of x or when we know what y is, right? So we have the same equation here. We're going to keep working with that same equation. And if we know that f of x equals 0, then we can plug in 0 in for f of x. Not just x, right? Not just x, but the actual function. So if the function equals 0, so I'm going to go ahead and put in 0 equals -2 x plus 3 squared plus 4. So this is the type of question where it might say, how can I find x values when I know y values? How can I find x's when I know y? If I want to get x by itself, how can I go about doing that? If I want to get x by itself. What would be my first
You
step?
inverse your operations.
I inverse my operation. So which one? What should I do first?
-2.
You want to get rid of the -2?
Mm-hmm.
How do I do that?
You divide the 0 by 2.
So if I divide by -2, I also have to divide everything by -2. So I can, right? So I can do that. Let's see. So I have 0 over -2 is 0. This would cancel here. I have x plus 3 squared, and I have minus 2. All right. Okay, how do I still need to get x by itself. How can I get x by itself here?
+2.
Plus 2, sweet, Kimbo. So I have 0 plus 2 would be 2. X plus 3 squared. Okay, how do I get rid of that square? Like, what's the opposite of a square?
Radical.
Radical, sweet. Square root like that. So I'm going to leave it with plus or minus the square root of 2. And then the square root and the square will cancel, leave me with just x plus 3. I don't need those parentheses anymore. I'm going to subtract 3 on both sides. And I get plus or minus the square root of 2 minus 3. Why is it super important to have the plus or minus there?
2 negatives cancel out.
2 negatives cancel out. So then so when you take a square root, you always have one positive version and one negative version for the exact reason like Ali said, which is that we would have like a negative would make a positive. So when you square root it, you could end up with that negative number. So I have 2 answers here, right? I have 2 answers. Does anyone have a calculator on them? Who can pop this into their calculator?
Got one.
Sweet, pop it in.
How do you do the plus or minus on the?
Ooh, good question. So it's actually going to be 2 problems. So it's going to be square root of 2 minus 3, like the positive version, and also negative square root of 2 minus 3.
So for the positive square root of 2 minus 3, it's negative 1.586. That's rounded.
Cool.
And for your negative 1, it's going to be negative 4.14. No, negative 4.414.
Negative 4.414.
Yep.
Amazing. Thanks, Sally. Okay, so if I know that these are my 2 answers, where are they on the graph? What does it mean on the graph for f of x to be equal to 0, for y to be equal to 0?
Those are your x-intercept points.
Yeah, those are my x-intercepts because y is 0. If y is 0 here, right, then I would see negative 1.586 or whatever that is. And I would see negative 4.414. And I can see that point there. Right, so if f of x equals 0, these are my my x-intercepts. Those are my x-intercepts. So where on the graph would it be if it was f of x equals negative 4? I want you to think about that. Think about that. Where would these points be? Because we actually don't need to do any calculations for this. Go ahead and type what you think x is when f of x equals negative 4. Go ahead and type that, privately chat it to me when you're ready. Try to zoom in here. I'm seeing a few people with their ideas are negative 1 and 5. Seeing a few people with their idea is 2. Eric Ahumada. Did I say your name right?
Yeah.
Nice. Can you talk to us about, you said it was -1 and -5. Can you talk to us about why you put it there?
I just looked at the line of the -4y, and I saw it intercepted at -1, and it intercepted at -5.
So you're talking about this point here and this point here?
Yeah.
Nice. And so then we can trace up to the x-axis and see -1 and -5. Cool. Thanks, Eric. Someone who originally thought that their idea was 2, right? So if you originally thought that your idea was 2, can you tell us, 1, why you thought it was 2 to begin with and why you've now changed your mind? Someone who originally thought their answer was 2. Araceli, can I ask you?
Since we had solved it earlier, then I thought that it would probably be the same answer.
Oh, tell me about what you mean about solving earlier.
So when we plugged in, oh, I see my mistake. I confused. So since -4 in the first one was in the x value, then I confused it.
I love that. Thank you for correcting your own mistake. I think that it is so important to think about like when we can change our minds about things. I think that's really important. So originally, Araceli, you were thinking, oh, well, -4 went with 2 before, so why wouldn't -4 go with 2 now? Does that seem like a good sum up of what you're saying?
Yeah.
Yeah, so -4 though just changed locations here. So that changed a little bit about where things was. Thank you, Araceli. Thank you. Cool. So we can see now, so if this is now our y value, right? It's basically saying our y value is -4, right? Where are the x's? Well, there's 2 points where there are x's, at -1, -4, and at -5, -4. Right? These would be my x at values. Okay. So wait. Oh, we talked about this in the graph already. So we can see those points there. We have our y values and our x values. Okay. For today, I want to make sure that we know what we're doing. I know one of the requests was for more structured note time. I'm still trying to figure out how to do that because I can't like physically hand you a piece of paper. So please let me know if you have any suggestions for how to make the notes more structured. For our time today, I'm gonna try our breakout rooms and see what happens. I have entered all of your emails in the way that Zoom told me to, but I don't know if it's gonna work. So you have 3 options for breakout rooms. Number 1, you go to a breakout room and you work with other people. If you choose this, you should have your camera on, right? I will come into your little groups and I will see if you have your camera on or not. That being said, you can just tell your group why your camera's not on, and then that's okay too. Okay, so you should have your camera on and you should be ready to work together in a kind way, right? So kind, respectful, that's the name of the game. That's the first option. The second option, which some people have been using this past week, is to stay with me and to go through the assignment together, right? I'm happy to do that. I'm really excited. I'm a teacher. I love teaching. So if that is true, then you just ignore the breakout room. You can just cancel it or just like let it go away. It'll go away after a while. And you just stay with me. And your third option is to work independently. If you're someone who likes to work independently, you also should stay in Miss Mac's room, like stay in my Zoom room. You can work on your own. You don't have to do what we're doing, but work on your own. In that case, you're just going to ignore the breakout room invitation as well. Okay. So you have those 3 options. I want you to think about the one that works best for you. While I try our new breakout room, let us see. Well, it looks like 3 people have Zoom accounts, so they're able to go to their rooms. Yeah, y'all, my plan did not work. I wish I could share with you what happened. I could show you what happened. But essentially what happened is when I pressed the breakout rooms this time, because we like set up the breakout rooms, Kimberly, Melissa, and Giselle are in their appropriate rooms. but everyone else is unassigned to their rooms. Kimberly, Melissa, and Giselle, maybe you can help us troubleshoot this. Could one of you guys tell us, like, what, do you do something different? Do you just like click the link? What do you do differently that allowed you to get into a room? Kimberly?
You just have to have an account.
You just have to have an account. Did you just like make an account?
Yeah, I made it with the school, you know.
Did you download like the little like Zoom client or anything?
Yeah, I downloaded the app on my phone.
Oh, are you on your phone right now?
Yep.
Got it. Okay. Giselle and Kimberly, are you guys also on your phone?
Yeah.
Yeah. Kimberly, are you?
No.
No. What did you do on your computer?
I actually just went to the website and I made one, and it said like it gives you an option that the school like lets you, that the school is making you make an account, like you're using it for school. And then I signed in on the app that my computer lets me download.
Ooh, okay. So you got like an actual, so like how Google or how Gmail is like down on the bottom of your screen. There's also like a Zoom thing down there now, like an app or an extension.
Yeah. Yeah.
Oh, nice. Okay. Well, thank you to the expertise from Kimberly, Mel, and Giselle. If you guys would like to continue to work in your breakout rooms, then that seems like the best option would be to go to the Zoom account and make a school Zoom account, so that we can do that. So for right now, I am going to recreate all the rooms. I apologize, they're going to be random one more time. So they will be random. I apologize. If you don't want to go to them, you can stay and work on the assignment with me. That's totally fine. So I'm going to create these rooms. If you would like to go to the rooms, you're welcome to go there and work with other people. If you think that that is awkward and you don't want to, you're welcome to stay here and either work with me or work independently. So I'm going to go ahead and open these rooms. Take them if you wish. If you don't want them, you can just ignore it and we'll work on the practice. For anybody who's staying with me, you can go to Canvas and find assignment 3. While I pull it up here. Cool. Looks like some people headed out. All right. Cool. Okay, team. If you are here with me, hi friend, how are you doing? Can you give me a thumbs up if you are gonna like hang out with us, and a thumbs down if you're working independently? Thumbs up if you're working with me, thumbs down if you're working independently. Cool. Okay, if you are working independently, you can go ahead and tune me out, spend the next 5 minutes hanging out. If you're working with me, let's jump in. So what would I title the notes? Oh, great question. Today, I would title the notes function notation. That is the title for today, function notation. Great question. Thank you for asking. Okay, so for part A, it says for each of the following, use the given function to calculate either the y value given x or the x values given the y value. Use the equation, but verify your algebraic results using the given graph. Okay, so it says use the equation. We're going to do it algebraically, like with the algebra, the first way that we did it. But we're also going to verify, which means make sure that it's correct using the graph, right? So for me personally, I think it's actually honestly easier to use the graph and then I'll check using my algebra. So it says find the value of g of -6. So my x value is -6. I'm going to go on the x-axis out to -6. And then I'm going to find the graph. go out to -6, and I'm going to find the graph, and I can see that it is down here at -1. So I know the answer for number 1 is going to be -1. I'm going to do the same for number 2, find the value of g of 1. Is there someone who thinks they know what the value of g of 1 is?
-2.
-2, how did you do that?
I just looked at the graph.
Just looked at the graph. Tell us more, Emma.
So it says that we're finding g of 1. So I went to 1 on the x-axis, and then I dragged my finger down until I saw the line.
Nice. So you got -2. So we know that answer is going to be -2, yeah? Cool. And then it says, for what values of x does g of x equal -4? So in this case, are they giving me x or are they giving me y?
Y.
Yeah, y. They're giving me y. So if they're giving me y, I'm going to go on the y-axis, and then I'm going to go ahead and find out where those points are. How many answers are there for number 3?
2.
2, yeah. Tell me more about that. Good job. So there are 2 places where it touches. So what are the x values that go with them?
-1 and -3.
Yeah, -1 and -3. So this answer is going to be -1 and -3. All right. And then it says, for what values of x does g of x equal 5? Okay, so are they giving me x here or are they giving me y?
Y.
Yeah, they're giving me y here. So on my y-axis, do my numbers go up to 5?
Yeah.
I mean, eventually, yeah, right? Like 3, 4, 5. But like, I don't know, like eventually this will come out here and this will come out there, and then eventually it will hit up there. But I don't know what those are. So for this one, I'm only going to be able to find it algebraically. Right, so I'm going to have to do some algebra for this one. I don't know for sure. Okay. So they give me the equation down here. Right, they give me the equation down here. So for number 1, I'm going to go ahead. Wow, it's annoying I didn't leave myself any space in the room right here. I'm going to write g of x equals absolute value, x plus 2 minus 5, like that. If I was doing number 1, what would I do here? So I want to find g of -6. What would I do?
You're plugging in -6 to where the x is.
Yes, absolutely. X is turning into -6. So I have -6 plus 2 minus 5, which would be -4. Absolute value of -4 would be +4 minus 5 would be -1. -1. Is that what we got when we checked with the graph? Yes, we did it. Right? We checked when we did it algebraically, we got the same thing as when we did it on the graph. Okay. I recognize that it is almost 10:30, so I want to just show you number 3. Number 3, if I have g of x equals this equation, and they tell me that g of x equals -4, then I'm going to plug in -4 over here for g of x. And then I'm going to solve for x. So add the 5 over, split them up into 2 equations. So I'm going to add 5 on both sides. I should get 1 is equal to the absolute value of x plus 2. Remember, when you have absolute value, it turns into 2 equations. So +1 could equal x plus 2, or -1 could equal x plus 2. Add 2 on both sides. I'm sorry, subtract 2 on both sides. We get x equals -1. And subtract 2 here, x equals -3. Okay. I recognize that it is 10:30, so I want to let you guys go, but I will be here all day if you need help, so please let me know. If you want to come back to Zoom, we can work together. If you want to come to office hours, I'm here from 3:50 to 4 today. If you want to hang out now, you can. Otherwise, I will see you guys soon. See you guys soon. Bye, y'all. If you're just coming back from breakout rooms, I know we didn't have too much time to work today, but did want to say thanks for hanging out. If you want to work with your own teams in breakout rooms, please make sure that you download the app and make an account for next time. So I will see you guys later. Have a great day.
Goodbye, miss. Enjoy your day.
Goodbye. Goodbye. Thanks for your help today, Galilee.
Yep.